I'll list the topics, okay? I'll go back to my syllabus since the last test, and we'll probably even do it today while we're together. But one thing you know will be this analyzing graphs, okay? To where you've had a couple of sheets that hopefully you've kept up with and you can study. I think a lot of girls like for me to post blank ones, and you can try again and compare the answers that either I've given you or you've gotten in class. And I'll probably even give you one to practice that we haven't done together with the answers provided, okay? So a great way to study for analyzing graphs, which is like this, or that worksheet we've done it a lot. I would expect like a page of the test to look like this, because I could find out a lot, like when's it increasing, when's it decreasing, all the stuff that I've taught you, max and min and stuff like that, okay? So that'll be part of the test. There's some delta mass I can give you on that that can help you. So when you read it, it'll say like analyzing graphs. And then out to the side of the assignment, when I post it, it's not posted yet, I'll say, like study the worksheets on analyzing graphs that look like this, and delta mass. Like I'll tell you like what component to study for that, okay? And then if you need more, email me like for my pre-cal test tomorrow, a couple of students wanted more practice on something that we're actually sort of doing today, composite functions. And I sort of made up another worksheet and sent it to them with the answers, but I sent it to the whole class, even though 2 or 3 people had asked for it, because I thought like everybody would benefit. So anyway, here's our pictures of the husky with the butterfly. Just stayed on his head for a long time.
That is so cute. That gives me hope for him.
Isn't that adorable? It just melted my heart. All right. And you could tell he's so confused.
Yeah.
So what do I do? What do I do? Okay, so here we go. Looking at your sheet. So instead of saying, do you have specific questions? Let me just talk about it. All right, so roughly it looks like this. It's a little smoother curve through there. Okay, so that's the picture you're looking at. I had you draw arrows on it. All right. And so the domain was technically negative infinity to positive infinity. If I give you one on the test also that like does this, I'll put big dots that you can see to where if you know the domain just goes from here to here. Okay? All right. And then moving on. The range was from negative 35 to infinity. Was everybody okay with that?
Yes.
Negative 35 to infinity. All right, so on the next one, if I ask you where f of x equals 0, okay, that means I want to find out every time that the y is 0. Like what x's will make that happen? And it happens here, here, and here. Now, but the way I worded the question, do you see I already know the y value is 0? I just wanted the x's. So technically you should have said it happens when x is right here, which was negative 4, and when x is right here, which was 1, and when x is right here, which was 5. I'm not going to count off, nor did I count off if you gave me the whole point, negative 4 comma 0. But this is, we did this in the last class. If I ask you where f of x equals 2, you would like do this. If I ask you where f of x equals 0, you would try to just think all the times it would equal that. Do y'all see how I'm doing y values here up and down? Okay, so I'll leave that aside because I'll need that later. All right, so now the next one, the x-intercepts, technically on the 4th question, I would have taken this for the x-intercepts. But technically, when you give x-intercepts, some teachers, after you have my class, might expect you to actually list them as points. So this is where it intersects the y-axis right here. I'm sorry, the x-axis. That's why they're called x-intercepts. Okay, it didn't count off, but that's why you might see some pink writing, meaning when you leave my class next year, you might have like Miss O'D or somebody, and they might require x-intercepts to be written as points. Okay, Yana?
So when you say intercepts, you want them to be written as points, but if it's just like what does, or f of x equals 0, what is x?
Well, there's no
is-
reason to write f of x equals 0 as points.
Yeah.
Because I already gave you the answer, and I just want to know the x values. That's all I asked for. If I say f of x equals 0, it's like if I said, Miss Holder, what's your first name? She's not going to say Gabby Holder. If I say Miss Holder, what's your first name? She'll just say Gabby. Okay? So do you see the difference?
Yes.
Okay. Great question. All right, let's move on. What is f of 0? No reason to repeat the point like Yana and I were talking about. You actually find f of 0, and the answer is just -5. I know your first name now. I need your last name. So getting used to the notation, can y'all tell, is a big part of this class. Okay? The y-intercept, technically, and it landed about right here, actually, if I put the axis in. This is not drawn to scale, but the y-intercept was about right there. And notice you had to struggle with, I wasn't counting by ones, we were counting by fives, and I heard your groups discussing that. And so the y-intercept, technically, you should say is 0, -5. All right, then name any local maximums. If somebody says maximum value, you only want the y. The way I worded it, I'd probably give the whole point. All right, if I'm looking for local, I also might use the word relative. Local maximums is all the hills, only the hills, okay? So I see a hill right here, and as I'm traveling along, that's what's called a local maximum as I'm moving along my graph. So this right here is a local maximum, and so that answer is 1, 0. I would have taken 0 also. Naming any local minimums, and you had to estimate these. And so I took different estimates, but they're valleys. If you want to write yourself a note, minimums are valleys, and there's a minimum here, and there's a minimum here. This minimum occurred at -35. It actually was at about -2.5, -35. You can't read that. Hang on, let me move this. Okay. So, sorry, it's got a mind of its own for a minute. I don't know what's happening. Okay. Just a second, Bailey, I'll get to you. This is like -2.5, -35, and then I have another minimum right there at about 3.8, -18 if you're counting by fives. And I took estimates of those also. Some people said -37, some people said -17 for this one. Some people thought this was 3.7 instead of 3.8. That's okay. They're just estimates. Those are both relative to the people that are around. Those are minimums. If I ask for the minimum value, all you say is the y. If I say, where are the minimums, you should give the whole point. Okay? Bailey.
You said for name any local maximum, you would accept 0.
You know what? It depends on how they wrote it, because the maximum really doesn't occur when x is 0.
Yeah. So you wouldn't accept 0.
No, I don't think I could now because I don't know where that was. I don't know what I did on your paper, but on the test I'd probably count off for that.
Yeah.
Yeah. So let's go back. I'm kind of going back on what I said just a second ago. If I said, what is the maximum, and you say 5, I don't really know if you mean when x is 5 or when y is 5. So you'd have to be more clear. Okay? Now, Bailey, let's kind of go into the next question, though. It says, what is the absolute maximum? What's the word I see here? Absolute maximum value. I only want to know the y then, how high it went. So what was the absolute maximum value? Did it ever quit going up? It just kept doing this, didn't it? Okay, it kept going up like this and up like this. So the other day, just in our hurry to end class and get your quiz done, I'll let some of you write down infinity. But you'd really say none. There is no maximum value. So the acceptable answer, if it goes on and on forever, is there is no max. I got to be careful about that because another teacher would not accept infinity as a maximum. That would not make sense to them. I just understood what y'all were thinking, okay? The absolute lowest number that you found was -35. If you gave me the whole point, though, on the test, I would not count off. All right? If you gave me the whole point, I would not count off, but really in the future, you're just starting. By the time they get to calculus, if I use the word value, they tell me the lowest y, or if I ask for absolute maximum value, they tell me the highest y, if the word value is used. Okay? Yana?
So always for the absolute maximum and the absolute minimum, you would accept one number, like one instead of.
Only if I say
ones?
value. If I say value, I want one number. If I don't say value, if I say absolute maximum, give me the whole point. Okay? All right. Name the intervals on the graph is increasing. Most everybody got that right. It was increasing from here to here. It was increasing in this blue part right here, and then it increased again. And most people got that interval right. It was negative 2.5 to 1 and 3.8 to infinity. Okay? Make sure that when you do increasing, decreasing, you tell me like across when it happens. You do it in terms of x. It's probably the most missed thing on a test this time of year. I want to know when or where it's increasing. So you're doing your x values during that time frame, okay? And again, that's pretty normal. When people talk about maybe their children, they'll say, oh my gosh, they went through a growth spurt in middle school. They don't really tell me what you weighed or how tall you are. Do y'all see? They're not telling me the values. They're telling me when it happens. Or I could say, maybe have a friend that made lots of money in 2008. You could then ask the question, how much money did they make? And that's a different conversation. Do y'all see what I mean? So we naturally do that. You could maybe go, last season I ran my best times. I still don't know what your best times were, but normally that's how we talk, like when it happens, okay? It was decreasing all the other times that aren't blue, and so it was decreasing. I don't know why this pen won't cooperate. It keeps changing back to thick. All right, so it's decreasing from negative infinity to negative 2.5, and then decreasing again from 1 to about 3.8. All right, and then where is f of x equal negative 20? I've left this line here for this purpose. I would go down like this until I hit negative 20. All right, so right here, it hits negative 20 in two places. If you look at your sheet if you haven't done this, and take your pen down to negative 20 and go across. Do you see you'll find two answers at negative 20? You'll find one here and one here. Now look at, this is what Yana was asking me. And if I say, where does f of x equal negative 20? I'm only asking for the x's. Do y'all see that? I already know it equals negative 20. I want to know when it happens. And it happened around negative 1 and negative 3.5. That's when x is negative 1 and x is negative 3.5. And then f of 3, if you followed it, was around negative 15. I took something close to that. Any questions? All right, so we've done a lot of that. And there'll be a page where I give you a graph and ask you these similar questions. Okay? All right. And I'll send you more practice. So now let's look at your homework for today. By the way, this was what the other one looked like that was similar. You should have that one. And I need to be a whole lot better at putting dates on it. Maybe I'll finally get the hang of that so I can refer to them by date. All right, so homework for today. I don't think I brought my sheet up, so I'm going to probably want to borrow somebody's for a second while I write the problems down. On the first sheet, you had functions given to, On the first sheet, you had functions given to you, right? What was f of x?
2x minus 3.
And g of x?
X squared minus 1.
Okay. And number 1 was f of 2. All right, I want to see y'all do this tomorrow. You locate your function. On Monday, okay? You locate your function, and when you write it down, do y'all all see f is 2x minus 3? Please do this. 2x minus 3, okay? Now, what have I asked you to put in for x? 2. And so you get 4 minus 3, so did y'all all get 1 for that? All right, number 2. What was number 2? G of 2. So that means I'm going to take blank squared minus 1. Please put parentheses. It can make a difference with your positives and negatives. I'm putting in 2, and I got 4 minus 1. Did you get 3? Okay, number 3.
2. F of negative 1.
I'm sorry, I didn't get
Negative 1.
f of negative 1. All right, back to f. 2 blank minus 3. I'm going to fill in negative 1. So I get negative 2 minus 3. Check and see if you got negative 5. All right. Number 4. What is it?
G of negative 1.
Okay, really important here. If you don't put this in parentheses, you could easily miss it, especially if you're typing it in your calculator. Negative is also being squared, the negative and the 1, which makes the whole thing positive. So that gave me 1 minus 1 is 0. Please don't ever stop putting those parentheses everywhere you see an X. Number 5. F of 3 plus g of 1. And I kind of sprung that on you on a homework recently, and you're all like, what is this? Okay, but you're probably better at it now. F of 3, I'm going to go find f of 3, 2x minus 3. Let's just do that part. I'm going to fill in 3. And I get 6 minus 3, which is 3. Then I'm going to add in g of 1. G is x squared minus 1. When I put in 1, I get 1 minus 1, which is 0. And then what do I want you to do with the two answers? Add them together, and you get 3. We're going to actually do some more of this after the test, after Thanksgiving. But I'm getting you started on the simple parts of it right now, so we can build on it after. This is called operations with functions. Okay? How is this real life stuff? Okay? What if you were going to do the MET project, which y'all did last year, right?
No.
You're in ninth grade. Okay. So for some reason I thought you were in 10th grade for 13 seconds. I'm sorry. So you're in 9th grade. So when you do the MET project, I honestly don't know how it works. But suppose that Bailey and Daniela and Eliza were in a group to do the MET project, and Bailey's job was to come up with the idea, and Daniela's job was to make the 3D image, and Eliza's was the one to do like a virtual simulation. Do y'all see that's an f of x plus g of x plus h of x? Okay? All right. And so certainly I think I don't even need to stand here and talk about how much that happens in real life and work, where I do something, somebody else does something, somebody else does something, and we put it together, and that's our product. Okay? F of 6, number 6 was G of 3 minus f of 2. All right, so for g of 3, I said blank squared minus 1, and I put in 3, minus f of 2. I'm going to wait and subtract them after I get it right. After I get it. Did y'all get 8 for g of 3? And then f of 2 is blank squared minus 1, 2 squared minus 1. That gives me 3. And then what were you supposed to do with them? Subtract them. Did anybody besides me get 5?
I got 7. Yeah, I got 7. I got 1.
Oh, you know what? That's because, whoa, hang on.
Yeah.
Oh, I used the wrong equations. I'm sorry, I did it wrong. I used the wrong equations. For F, do y'all see I used the wrong equation for F?
Yeah.
Okay, so be sure you follow the directions. G, I use x squared minus 1. For f of 2, I should have used 2x minus 3. 2x minus 3, I'm going to fill in 2. So this one was 9 minus 1 was 8. This one was 4 minus 3, which is 1. Then you subtract them, and did a lot of y'all get 7?
Yeah.
Okay, are y'all okay with that? Questions, Ella?
I got 16. I don't know why.
Did you see how I just did it?
Yeah.
Mister, you can't get one.
What?
I think I like subtracted all of them, so I did like 9 minus 4 minus 4 minus 3.
That's why I'm telling you to do what, watch this. Maybe this is what happened to a few people. If you do this, if you do g of 3 minus f of 2, everybody, every eye up on the board, okay? If you do that, you're going to miss it. Guaranteed. Because if you do that, what's the only thing that you're really going to be subtracting in this part? All you're going to be subtracting is this 4, right? What I mean by that is there's a big difference in these two statements. What if I want to say 6 minus 2, and then I want to subtract, let's say I have an f of x minus g of x. And I get 6 minus 2, and g of x is like 8 minus 4. Then the answer to f is 4. The answer to g is 4, and I subtract them and I get 0. If you'd run it all together, 6 minus 2 minus 8 minus 4. Did y'all see what some people are doing? Run it all together. What's 6 minus 2? 4. 4 minus 8, negative 4. Minus 4 is negative 8. Not the right answer. The right answer is 0. Watch this. Yeah, you have to what?
You have to solve like individually each one, and then after you get that.
Yes, you're exactly right, Maria. That's super safe, and like I said, that's what I would do for now. I would solve each one and then subtract them. The reason that's messing up, and every eye look up here, you should do this instead, not that. You should do this instead. Now you're subtracting what you're supposed to. There's a big difference in this statement and this statement. Do y'all see what I mean? Okay? So if you wrote it in a long line, just wrote down f of x minus g of x without any parentheses at all, you're guaranteed to miss it. Because you're not subtracting what you're supposed to be subtracting. Girls, watch. If you write it out like this, 6 minus 2 minus 8 minus 4, you only end up subtracting the 8. You never really say minus to the negative 4. Do y'all see what I mean? Unless you put it in parentheses. Then it's all subtracted. So what you should always do if you're going to string it along, let's go back to this slide. Was it this one? It was this one, right? This is what Maria and I are talking about. It's a whole lot safer to just find f of whatever and g of whatever and then add or subtract them, okay? But what we will get to after the next test, and you could do it on this test if you want to, is reserve a spot for g of 3, reserve a spot for f of 2, and make sure you subtract them. Don't think about your question, think about what I'm saying. It's very, very different to say 5 plus 4 minus 3 minus 2 than to say 5 plus 4 minus 3 minus 2. What gets subtracted in the second scenario? The 3 and the 2. What gets subtracted in the first scenario? Just the 4 and 3. The 2's not even considered in it, is it? Okay? And so if you want to string them all along, you better separate them as here's this answer, and then here's this answer, or you're going to miss it. So let's do it again. G of 3, I filled in 3, and I got 8. F of 2, I filled in 2, and I got 1, and so the answer is 7. Hopefully I addressed whatever you did wrong. Okay? All right, Yana, did you still have a question?
Well, so I was just gonna ask, so then you're going to put parentheses, right, around the 2x minus 3 and parentheses for the x.
Yes. Exactly. All right, what number are we on? 7? All right, what's 7?
F of G of 3. F G 3.
Okay,
F of G of 3.
very good. You read it F of G of 3. Let me show you this real quickly. You might even see it written like this someday. In fact, I had some teachers that called it fog, like a foggy day. Fog and golf. It's written like that because this would mean you're multiplying the two. Do y'all see what I mean? Like a solid dot to all of us by now in our lifetime means multiply. I haven't asked you to do that yet. I feel like I could and you'd be fine with it. We'll do it after Thanksgiving. In this scenario, you would find F of 3 and G of 3, and instead of add or subtract them, you'd multiply them. Okay? You're not going to have to do that on the test Monday. In this scenario, though, it's a whole other ballgame. F, you know how all the time we run around going F of 5? Now this is F of G of 5. And so that's why that little O is there. It means like of. I hate to write it that way. I much prefer this method. I will always write it like that for you. But I don't know what you're going to see in Delta Math or anything. So in the future, if you see somebody go G of F of X, I'd rewrite it G of F of X. Okay? Margot? Oh, it's a bad time to go to the bathroom. You can go if you can't wait, and if you promise to, I don't know, this is too important. Ugh. But you know where it is in the video, maybe. So, yeah. I don't know, there's going to be a good time, though, now that I think about it. We have over 30 more minutes. So, you just do what you need to do. But just if you get up and go to the bathroom in the next minute, just kind of notice where we are on number 7, and you could fast forward and pick up because this is super important. Girls, you know how I said if Bailey and Daniela and Eliza were doing the MET project? I've done this before where I give projects where people have components, and let's put me in the group too, okay? So maybe my job was to, do something else for the MET project. And what if I didn't do my part? There is a chance that the whole team would suffer because mine just never showed up. But a lot of times teachers will go, well, Bailey, I'll grade you on your part, and Daniela and Liza, y'all did your job, so I'll give you 100, and, worthless Becky Lazari, we'll give her a 0, right? Okay? That can happen. The math department is notoriously famous, unfortunately, for getting to meetings late. So I've made a really vested interest this year in being at meetings a little bit early, because it's painfully obvious when everybody's sitting there and 3 or 4 of the math teachers walk in 5 minutes late, so much so that it's been commented on. It's usually because we have so many people attached to us that we're answering questions. It's not, and we're just saying, oh, I got to go to the meeting. The math center is just so easily accessible. I mean, who's going to climb up 6 flights of stairs to go talk to the other teachers if you could pop in the math center on the first floor? So we're real busy. Not an excuse for being late to meetings, right? However, now that I'm making a really, intentional effort to be there early, sitting down before it starts, then if 2 math teachers walk in, I shouldn't get penalized for that, should I? Hopefully they may not. They'll go there, they could easily go lump us all in together and go, there's those math teachers again, they're late, and they may never noticed I was sitting there, okay? But if somebody said something to me, if all of a sudden I got an email, like if y'all are late one more time, you're fired, I would want to go, I got pictures of me sitting at that meeting every time. Do you see how that's an individual thing? So if that was like an f of g plus h of 3 plus g of 3, I don't know what all I just said. Okay, now here's a whole nother, that's a standalone. Y'all listen. I'm here, I'm at the meeting, don't penalize me, right? Okay, so I can do it myself. There's a whole nother thing that happens in real life though called a composite function, okay? Which is a lot more intense. It just happened to one of my friends in their business, downtown New York, in a like finance advertising business. Somebody made a mistake. I can't remember the number. I should remember the number because it makes a big difference. It was either a $40,000 mistake or a $400,000 mistake. I can't remember which one. Because I grade papers, I don't deal with money. But I bet they know which one it is. So let's say 40,000. Let's give them a little bit of grace. So if I am working for Sarah's company, okay, and I make a $40,000 mistake, she can point her finger at me all she wants to as the client start calling, complaining, or the police show up or whatever. Who's going to bear the brunt of all of that? Who's going to be in the news, me or Sarah? Sarah's going to be in the news, sorry. Okay? You know, like, because she hired me and she trusts me and she can point the finger at me all she wants to, but people are going to go, all they're going to remember is what Sarah did, okay? There's a real story that I told you at the beginning of the year where NASA made a mistake, and I think we talked about disasters with unit conversions. And they lost a $1 million mission to Mars. Thank goodness people were on it. Did I tell y'all that?
Yeah.
Okay, I thought so. It really was more intense than that. It was what we call a composite function, okay? So let's say that we'll just use Sarah and myself. I'm Lockheed Martin, and Sarah is NASA. NASA quite often hires Lockheed Martin engineers to do their computations. So I'm Lockheed Martin doing my computations, this fancy engineer. I hand it back to NASA, they put it in their computer program, they launch millions of dollars space shuttle to go to Mars and take pictures. It's gone forever. It was my mistake. Who's going to blame? And the whole story, if you look up the headlines, is who? NASA. Probably I'm one of the very few people that knows that it was Lockheed Martin's error. Do y'all see what I mean? That's a composite function. That's like, it's not side by side and I did my project. It's like you're waiting for me to do my part so you can finish the project. Do y'all see the difference? Okay? So if you never do your part, then okay, so let's twist it around. Suppose in the MET project that I'm in the group of 4, and I'm supposed to do the research before they're even started. Like, do the research, find out how many gold boxes are at the MET, and we'll do something with gold boxes. And I just never do it. What happens to them? They can't even start. Like, they can't even do their components, right? Do y'all see they're waiting on me? Okay, so this composite function, I can't even do F until G does its job. Do y'all see what I mean? And also I told a couple of y'all today, it's like a scavenger hunt. It's really kind of fun. You get a clue and then you go on to the next clue. How many of y'all have ever done a scavenger hunt? Raise your hand. So you don't know what's happening on the scavenger hunt. You may get this little clue and it brings you into this room to look for a black marker. And what will you find on the black marker? Another what? Clue that may take you to the clock, and you pull it off the wall and look at the back of it. And you're getting more clues until you get to the final answer. Y'all with me? Okay. So what's your first clue up here on the board? What do you have to do very first? Sarah? I got to find G of 3 first. That's my first clue, okay? So I'm on my scavenger hunt, and I go to G of 3. So I'm going to find G of 3. All right, that's 3 squared minus 1, which is 8. Now I filled in my clue 3, and I got 8. What do I do with that clue? Girls, where's that send me next? To F. All right, so it's like this. F of G of 3. All right, so I'm going to do something kind of fancy here. Like this. Y'all watch. Here's our job. F of G of 3. Okay? So first, Sarah, we're going to find g of 3, right? All right, so we went and found g of 3, didn't we? And what did we find for g of 3? 8. So now what do I have to find? Did y'all see what just happened? Okay, so we found g of 3, which was 8. And now you can all find f of 8. So check and make sure you did this right. F of 8 is 2x minus 3. I'm putting in 8. And so if anybody got 16 minus 3 or 13, you got that right. And you hadn't really even been taught how to do that, so that's good, okay? We've done it a little bit. All right, what's number 8?
So G of F of 4.
G of f of 4. Was there a question before I move on? Okay, G of f of 4. You've all been taught, G of f of 4, to work from the inside out, so what's your first clue? All right, so I'm going to go find f of 4 and write down what it equals in green, okay? F of 4 is over here. You can't barely read that green, so we'll use white. Okay, f of 4. So I'm going to go, f of 4 is 2 times 4 minus 3 is 5. So f of 4 is 5. So I take out f of 4 for g of f of 4. All right, so I take out f of 4 and I put in 5. Did y'all see what I mean? And then you go and find g of 5, which we'll do real quickly. G of 5 is 5 squared minus 1. You should have gotten 24. All right, is there another one? All right, next page you had a graph to read. So you see that algebra is, you do things graphically, numerically, and algebraically. So I get you used to all of those. All right, so, and Margot, feel free to go if you've got a handle on this, okay? So the first picture looked like, let me see yours, Jillian. All right, so the first picture had something like this. And, I'm sorry, second picture had something like this. Okay, and this one was F and this one was G. All right, number 1 on that page, or whatever number, what number are we on? Did I start over? I start, what am I on?
A.
Oh, so I didn't even number it. Okay, so A was what? F of 1. And so you should have gone to 1 and counted up. And what is F of 1? 2. Okay, I gave you the X, you give me the Y. B?
G of 0.
G of 0. You go to G, go to 0. Did y'all get 4?
Yes.
C.
G of F of 2.
G, so I jumped in on composite functions, okay? So we're going on our scavenger hunt. What do you have to find first? F of 2. So I'm going to go to F of 2, which I got 0. And now I've got to find G of 0, which took me to 4. Y'all okay with that?
Yes.
All right, D. F of G of 1. First clue?
G of 1.
So I'm over here at G. G of 1, was it 3?
Yeah.
All right, so you found G of 1, so you fill it in, 3. And now you've got to go find F of 3, which was that 1? 2. Okay? E? F of 4 minus G of 0, so we're starting in on these. F of 4 was 4. And G of 0 was 4. And so you get 0. So you're just doing commands. F? Was there a letter F?
G of 1 minus F of 0.
G of 1 minus F of 0. All right, so G of 1 was 3. And F of 0 was 4. 4. And so I got negative 1. And then is this the last one?
Yes.
F of 1. See, it looked kind of funny, didn't it? F of 1. Okay? So I'm going to find F of 1, which was 2. Was F of 1 2?
Yes.
Okay. So F of 1 is 2. So I'll find F of 1, I put in 2, and then I find f of 2, and my final answer is 0. Okay? All right, now let me make a list of topics that are on the test, and I will spell this out for you in assignments, and then we'll do something at the board. So I'm just going to look back through my syllabus since the last test and make sure I call everything out. One thing I know, okay, so it'll be analyze graphs, which you'll be able to study with, I'm sorry, I was thinking about something else, with Delta Math and with worksheets. Okay, I'll write it in real words for you on assignments. Another I know is even and odd. And after this test, we'll do a little bit more with even and odd, but for now, you'll be able to do it by the picture, okay? So you'll have to identify even and odd, which I think we almost only did those on worksheets, okay? I don't know that I found any good one. Yeah, it's too hard on Delta Math right now. Identify, you'll also have to complete the graph.
This is all on the website, right?
It's not, but it's going to be. I'll type it all up and post it. In Word, you don't even have to write this down. When you open assignments, it'll be like really written out in a nice way, okay? I just want to kind of skate through it right now. You'll also have to complete the graph where if I give you a picture like this, you complete it if it's even, you complete it if it's odd, okay? If it's even, it goes like this, okay? If it's odd, this piece is going to come through here, and where this bends away from the axis, this should bend away from the axis like that. Okay, there's some worksheets where you can practice that.
It's also 1-to-1.
And it's also a one-to-one function. Thank you so much, yes. I might ask you one-to-one, thank you, under the analyzed graph. Girls, I forgot to ask that on the one we just did that looked like this. This one is a function. Can y'all see that purple? All right, but how do you check one-to-one? Horizontal line test, is that one-to-one? No. Okay. All right. So I know that's on there. Evaluating functions. So all this f of x and g of x stuff. And composite functions. Okay? And if I can find some good Delta Math on that, I don't think I can. I've looked before, but I'll let you know. So what Maria was asking, I'll try to also kind of name the worksheets that you should, and from now on I need to always give you dates so I can refer to them that way. So every time I forget, y'all remind me, because I think I've only remembered once. Sorry, trying to get into my computer. Okay, so I'm looking up our calendar. Okay, so since the last test, we have Is this our third test or second test?
Third.
I thought third. Okay. Okay. So okay. So the first thing we did after the last test was that coloring activity. Remember where you were coloring increasing and decreasing? And so it'd be analyzed graphs, which we did some of today. Increasing, decreasing, and everything. Then we had parent-teacher conferences. Oh, another thing that would be on it is when is it less than 0, when is it greater than 0, where we did the underwater activity. Okay, so where is it less than 0 is negative, greater than 0 is positive. And then We did even and odd. And now we're on today. Okay. So, girls, I thought I had till, oh no, we can't do this thing. I kept thinking I had till 50. I wonder why y'all were moving so much. So, girls, you can leave and won't even get to do our fun little activity. We'll do it later to make me happy. Okay? It was so much fun. I thought I had 25 minutes. All right, bye. I'll post this.